Hello, class 11th physics, thermal properties of matter. Before to start, let's differentiate between heat and temperature. So, heat is the form of energy which transfers between systems to achieve thermal equilibrium. Bit complicated words I have used here. So, heat is the form of energy which transfers between system to achieve thermal equilibrium. That is, if this object and this object both um, are not in thermal equilibrium, it is at higher temperature, it is at lower temperature, so heat will flow from higher temperature to lower temperature, so that both the system will acquire same temperature means thermal equilibrium. So that transfer of energy is called heat. So actually heat is related to that thermal equilibrium, to achieve thermal equilibrium only. So we can't say that any energy can be heat. No, uh, only that energy which flows to achieve thermal equilibrium is called heat. And temperature, what is temperature then? So okay, to compare hotness and coldness, we need a certain parameter, and that parameter is called temperature. Okay, so uh, there are no fundamental formulae for to calculate heat or temperature, but in relation to other physical quantities, there are some formulae to related to them. So heat, we will give it symbol Q. I'm directly writing its unit, so its SI unit will be joule, because it is a form of energy. And commonly CGS unit, we can say CGS unit is erg, but for heat we can say traditional unit, and that is calorie. Where 1 calorie is equal to 4.186 joule. And what is 1 calorie? Actually, it is the amount of heat required to raise the temperature of water through 1 degree. And to be uh, very specified manner, we have to say temperature of water from 14.5 to 15.5. We'll discuss about it later on. Now, what is the formula for temperature? No formula, because it is a fundamental quantity. So I'm going to tell you its unit only, and which is Kelvin. SI unit is Kelvin. Other than that, common units are degree Celsius and degree Fahrenheit. So okay, uh, as I told you, we don't have particular formula to calculate heat, but uh, you might remember this formula for a heating element. So that heat, well, at that time we used to write H, because with the alphabet Q we used to express charge also. So H or Q, but H will also have different meanings. So H or Q, we will use the symbol Q for heat here. So this was the formula for a heating element. Other than that, there are so heat, we have to consider it uh, derived from some other effects. So some other work done or some other energies will be getting converted into heat. So there can be many formulae, but there will be some other parameters also, some other factors also, other terms. So here, um, to measure heat, we have a device. We have different devices, but most common device used in labs is calorimeter. And to measure temperature, we have thermometer. So we can have many type of thermometers, but the most important thing is different scales, different temperature scales. So we have three temperature scales: degree Celsius, degree Fahrenheit, and Kelvin. With Kelvin we don't put this degree, it depends upon simply divisions. So this is some traditional way, and this is a bit modern way. So now uh, there is a relation between all of three. This is the relation. Tc minus 0 upon 100 minus 0. What is this? I will explain you later. Tf minus 32 upon 212 minus 32. Okay, for Kelvin temperature, for this is also called absolute temperature, so we have to use symbol capital T only. Minus 273. Well, to be more precise, we have to write 0.15. You can avoid that, but when precision is required, then we have to go for these two decimal places also. 273.15 minus 373.15. What is the meaning of this? What are these numbers all about? So first let me write Tc upon 100 is equal to Tf minus 32 upon 180 is equal to T minus 273.15, which can be avoided, upon 100. And remember, what is the basis of this is, for Celsius scale, lower fixed point. Lower fixed point doesn't mean that we can't go below that. Lower fixed point means what is the reference for selecting that temperature scale. So lower fixed point is at 0 degree Celsius, at melting point of ice. The temperature at which ice start melting is taken as lower fixed point, and it is marked as 0 degree Celsius. And upper fixed point, it is put in boiling water, and where the temperature scale reached, marked that as 100 degree Celsius, so upper fixed point. Next, for degree Fahrenheit, same ice point or lower fixed point is marked as 32 degree Fahrenheit, and upper fixed point is marked as 212 degree Fahrenheit. And for Kelvin, lower fixed point is marked at 273. So and upper fixed point is 373.15. So this is the basis of